This video, we're going to talk about 1.1 Objective 5, where we solve applications involving functions. The National Weather Service releases approximately 70,000 radio sondes every year to collect data from the atmosphere. Attached to the balloon, a radiosonde rises at about 1,000 feet per minute until the balloon bursts in the upper atmosphere. Suppose a radiosonde is released from 0.8 feet above the ground. There's my initial height. And that 4 seconds later, it is 89 feet above the ground. So there's my f of 4 right there. Let f of t represent the height in feet that the radiosonde is above the ground. T seconds after it's released. So evaluate the average rate of change here. F of 4 is 89 minus f of 0 is 8 over 4 minus 0. This is going to be 81 over 4 is 20 and 1/4 or 20.25. It's going to be A. 20.25 feet per second for the first 4 seconds. A small rocket is launched vertically from the edge of a cliff, 375 feet off the ground at a speed of 200 feet per second. Its height above the ground is given by the function negative 25t squared plus 200t plus 375, where t represents time measured in seconds. Go ahead and stick this into your calculator if you want to see it, but it's this one because we have to start 375 feet off the ground and we're launched up, and it has to go up to a maximum before it comes back down to the ground and crashes down here. So assume the rocket is launched at t equals 0. What is the appropriate domain? So we're going to need to go 0 to something. We're going to have to figure out exactly at what time over here it crashes into the ground. That's about 10, but we can't say 10. So we're going to have to say negative 25 times t squared minus 8 plus 375. We're going to set that equal to 0. Negative 25 times t squared minus 8t, that is, equal to a negative 375. T squared minus 8t. It's going to be equal to 15. Check that out. Yes, positive 15. And a half of the middle number squared here is going to be 16. It's added to both sides. T minus 4 squared is equal to 31. T minus 4 is equal to plus or minus root 31. We're not going to want the negative option here because we don't want negative time. I'll go ahead and write plus or minus root 31 for right now. T equals 4 plus or minus root 31. If you check 4 minus root 31, you see it gives you negative time. So we're not interested in that. Our final time is in the positive direction here. And so this is 4 plus root 31. Now we're going to find where it reaches its highest point, and that's why I was trying to kind of complete the square here. So you can see that this is right here is negative 25 times t squared minus 8t plus 375, 0. This is f of t equals, and then I put a plus 16 in here, and we had to 16 times 25 is 400. So we have minus 400 plus 400 negative 25 times t minus 4 squared plus 775 right there happens when t is 4 and the height there is 775. So we want that in vertex form so we can read that and get the location of the vertex, which is the maximum. Again, we're doing this without any calculus. We'll learn how to do that later with calculus. A cylindrical tank with a cross-sectional area of 576 square centimeters is filled to a depth of 576 centimeters with water at t equals 0 seconds. A drain at the bottom of the tank with the area of 24 square centimeters is opened, allowing the water to flow out of the tank. The depth of the water in the tank at any time t greater than or equal to 0 seconds is given by the formula d of t is equal to the quantity of 24 minus 9/10 t, and then that quantity is squared. So calculate and interpret d of 0, that would be the depth of the water at time 0, which we know was 576. That was given to us in the problem. Don't even have to stick it in there to see that, but that is 24 squared. This is C, value of the depth of the water initially in the tank. And then how long will it take for the tank to empty? So we want 24 minus 9/10 t squared to be equal to 0. 24 minus 9/10 t will be equal to 0. Negative 9/10 t is equal to negative 24. That's going to be the same thing as 9t is equal to 240. So t is going to be 80 over 3. T is going to be 2 is 6. And then that's 6 gives me 18. And then this is 6, 6, 6 repeating because I keep putting more zeros and carrying more 2's like that. So it says to round to the nearest tenth will be 26.7. And that gives us a domain of time as 0 to 26.7 seconds approximately, since we rounded to the nearest tenth. All right, that's it for this video. We'll come back next time and find and simplify a function's difference quotient. I'll see you for the next video.